Here is my 1 hour stopwatch, consisting of a 5-5-5, a 4-4-5 tens, 4-4-5 11s, 1 AND logic gate, 4 7-segment displays, 2 buttons, capacitors, resistors, diodes, and much more. How this circuit functions is, first, this button will take a input from the voltage line into this pin, which causes nothing to happen. But once this button is clicked, it will give power to the 555, which is a oscillator currently. As you can see, has a capacitor, resistor, and the other resistor, which together cause this to produce an oscillating current. This current is then supplied to the 4510, which is a chip that can take an oscillating current and turn that into a counting current or count. And what this does is it takes the clock input here from this 555, and the 4510, every time the 555 oscillates, will count up 1. This 4510 can only produce binary numbers though. So in order to show it in a non-binary or decimal number on the 7-segment display, you need your 4511, which takes the inputs from the 4, 2, 8, and 1 pin of the 4510 and supplies a 7-segment display compatible output on the A, B, C, D, E, F, G pins. And those pins will then provide voltage to the 7-segment display and power each LED when necessary to show a binary number. Then the next part of the circuit is connecting these 4-5-10s so one doesn't light up independently. How this is done is the 4-5-10 will release a oscillating output from the carryout pin to the clock pin of this 4-5-10. The 4-5-10 will then create a count based on this oscillation, and this will oscillate every time it reaches 10 or 0. So when this reaches 0, this will turn to 1. It is then repeated throughout these 4-5-10s and 4-5-11s to cause the LEDs to light up in unison to create a count. The next part of the circuit is stopping these two 7-segment displays at 6. In order to do this, you must take the 4 and 2 outputs of the 4-5-10, these two, and wire them directly to a AND gate. You want to wire it to the 2 inputs of an AND gate, and an AND gate functions as a logic gate that will take 2 inputs and produce an output based on those 2 inputs. And the only output it can produce is high or low. And it'll produce a high output only when the first 2 meet the condition of high. So if these 2 pins are high, this will be high, which is then wired to the reset button of the 4-5-10, which causes this 4-5-10 to reset at 6, meaning it doesn't go past 6. It won't go to 7, 8, and 9, which is perfect for the circuit I am making. The only problem is if this resets at 6, then all of these, which are connected via this reset button, will also reset when this goes to 6. That's a very big problem. The way to counter that is through diodes. And the diodes are set up to each reset of the 4-5-10s to stop backflow into the reset. And even though this is still wired to this, it makes it so this whole count doesn't reset when this one goes to 6 or this goes to 6. Finally, there's the reset button, which is the reset to all of these, and will hard reset the entire count. Thank you. This is my 1 hour stopwatch,